Can you hear me now or not hearing anything still? Okay. Oh, you can hear me now. Oh, awesome. Sweet. You did it. Hey, everyone. Wow, I'm so glad this is working. Um, will this be archived? Yes, it will be. So this video will be recorded. I'm gonna cut it up into a video. So my video next Monday will actually be this live stream, but cut up into like a shorter form. Um, yeah. Hey everyone. Wow, there's so many people here. Uh, wow, this is this is awesome. So, um, yes, uh, yeah, no problem. Cozy nipples. That's a great name. Um, so the point of this live stream is I just want to go over the source code for my game, Escape from Complex 32. Uh, I think that it would be beneficial to kind of have an idea of like what maybe a complete game, albeit a small game, could look like. Because game architecture is kind of a topic that doesn't get talked about a lot, I think, and especially with like even in like big like engines like Unity or Unreal or Godot or whatever. Um, like game architecture is kind of like it's so it's such a weird interesting concept. It's like easy to talk about like, oh, how do I make this character controller, but like just the entire source code is kind of different. So yeah, let me jump right into my source code. So here I have my main file. I'll first go over basically my file structure. um, I have all these scripts basically, and I've organized them nicely, um, and uh, and then I'll just go quickly, brief overview over each of the files, and what each of them do, and also um, and then I'll go in depth into each file, and then I'll just kind of talk a little bit about what um, like how everything is tied together. So you'll see these comments here. These are from my Patreon supporters. So if you're a $5 patron, a Giant Squid patron, I usually send out the source code for my games, the files, and I leave a bunch of comments. So you can read them or you can ignore them for now. Hey everyone! Wow, like all these people that I've seen in my comments and stuff in my Discord and everything. It's good seeing everyone. Let's see. I don't know how to pronounce your name. Maheshinder, Sam Play, Eric, Seishin, White Brim, Cozy Nipples, Sunny Sun, Vernu, Non Billy, uh, Jimmy, David, Gov Bubs, of course, and Silent Judging. Hey everyone. Um, yeah, okay, so let me go over my file structure. So basically, I have, of course, you always have to have a main file. So this is where we are right now. But I have this background file. So this background is kind of what controls the infinitely scrolling walls um, on in my game. Like I've talked about it in my video, in my devlog. So I have one script that just kind of handles that entire scrolling effect. And then I have this obstacles folder. Okay, I can pull it up here actually. So this is my game. So this background, the game background.lua, and then obstacles folder. So this holds everything related to the obstacles. I actually have one. Actually have one like overarching obstacle class that everything extends from. And yeah, Sandy, hi. I am going to upload this whole stream, and I'll also be cutting up this live stream into like a shorter video. So if you miss anything, yeah, don't worry about it. So feel free to go to bed. Um, Yeah, so I have this obstacle. So every obstacle extends from this obstacle class, which makes things really easy because in the player class I handle collisions by checking the type. So that's kind of why that was important. So everything related to the obstacles is here. I also have a player class. Um, so this has to do with the player itself, um, and um, and then and then also the laser beam, the laser gun, the timer, and all that. Um, and yeah, and then I have the UI, and then I split that up into everything UI related. So that has to do with the results display and like showing the high score and everything. And then I have how I handle the scene transitions. I have two different scene files. So there's actually only two scenes in the game. There's the title scene, and also the title scene and the actual game scene. So these are these two files. They handle all the initialization, um, and uh, and then outside of the game stuff, I just have a globals. Oh, so the title scene, I mentioned that. Um, Outside of the game and the title, I have this globals file that handles a lot of things that basically is globally accessible that I use across the project. It's just nice to kind of organize it like that. And then I have a scene manager that manages like switching between scenes, the transitions, and then of course the main file. And the Narbalicious asks, does using object-oriented programming make your game more resource intensive? So that's a great question. The answer is no, because how object-oriented programming works is there's basically it's essentially a simple abstraction over your code. So it's just like not that much code that's wrapping around like your other code. So it's it's like a constant amount of code, so it doesn't like scale or anything. So basically, it's like it's technically you're technically running more code, but it's such a small negligible amount, and the organization benefits that come with it is and it's like worth it. So it's basically negligible. Is the answer to that question? So, but that's a great question. Um, yeah, like you might get like a little bit more like memory and usage and a little bit more execution time, but overall object oriented programming is you like that's not really a consideration when you're thinking about performance. Okay, so let me go through each of my scripts, or actually let's start off the main file first. But now I'm gonna after going over this overview, I'm gonna go into the main file, and then just talk about how things are structured. So of course I'm importing everything, the core libs, and then some of these scripts that I'm using, and that. Um, so here's I'm just doing some initialization stuff. So you'll notice that if you take out the comments, my main file is very clean. There's not that many lines, so it's like 3, 6, you know, 10 plus, it's like 20, 30 lines. Um, and the reason for that is because it just in terms of like a cognitive load, like I think like code architecture, um, like a personal opinion of mine is just, or not necessarily opinion, but like a lot of your work with code architecture is not necessarily has anything to do with like how the game runs, um, and also like how like efficient or things are, but it's more so that you can organize everything in your brain, and um, and it makes it so that uh, like when you add things or change things in your code, it's very like simple to do so, or it's enjoyable to write code. Is what I think is important of game architecture. And Gov asks, "Hey Squid, can you give an update on your Lua book?" So yes, I'm working on a book. It's kind of like a book, not really. It's like a PDF thing. Basically, it's like it's like expounding on my intro to Lua videos. So like Lua for beginners. Yeah, so I'm currently writing it right now. I've been a bit busy because I have a collab coming up that I'm working. So that's a little a secret collab that I'm putting some time into. But yeah, I wrote the introduction for the book, and I'm working on the other chapters right now. But hopefully, I'll be done in maybe 2 months. Um, yeah, so back to this. So back to my philosophy on the organization of code. That's kind of what I think is uh, is kind of like the main thing. So there's no like reason to have like a short main file other than the fact that it for me it's just easier to understand. So like I'm like not sticking that much stuff into this like a super long main file because like what you could easily fall into is you would have a main file that's like really really long, and basically you're just scrolling and scrolling trying to find different aspects of your code, and if you have to add something you're just like going jumping all over the place, and so like splitting things up into different files and abstracting them away is a good way to make it so that it's more enjoyable to write code and easier. So yeah, so basically all I'm doing is I'm setting a global variable, this max height, which I use to keep track of the max height, and then I load the game data. So this is actually part of the global file. Um, so I I I want to make a quick note on globals. So if you remember from if you watch my videos, I I talk a lot sometimes about like focusing on using local a lot instead of global uh, scoping. And the reason is because when you make a lot of globals, what happens is um, you have basically in essentially invisible lines of um, like data paths going across your entire code base. And what happens is it's very easy to lose track of your data that way. So it's like confusing to write and to update your code, because what could happen is you update a global variable. Let's say I change this to 1 instead. What happens is I don't actually know where this max height is used elsewhere in the code. Obviously you can search for it like max height. I could find it, but in reality, like it's easy to make changes to global variables and have it impact your entire code base and create bugs that you don't know about. So that's why I recommend limiting your scope to like locally, so you know that at the very least it's within this file. But or if it's in like a function, it's within the function. So this is, I believe, like one of the few. I have like 5 global variables in the entire project, and this is just one of them. I just found it easy to just have the max height because this is the only piece of data that I save, which I'll mention later. Fern News says, "Do you think it's possible to make an online game on the console?" So currently, there's no API available to developers to do any sort of like any sort of networking. But I believe Panic has said that they are currently it's in their backlog, or they might be working on it. Um, I do think there is a way that you can like kind of hack the API to access um, like the networking. I think I saw that somewhere in the Playdate Squad Discord. Someone was doing that, but as of now, I do not think so, or it's not recommended. But great question. Yeah, so I keep checking this max height global variable, one of the few global variables I have, and I load the game data. So I can pull up the globals file right now. So you can see not that many global functions that I'm using, but basically, I had these things not as globals, but I basically went back in my code and replaced them with these globals if I found that I was using a function like across multiple files. And there's not that many, but if there was, then I would kind of extract it into a global function, um, just to make it easier to use, um, and not to reduce code duplication. So save game data. This is just this function. I'm saving the max height into the data store. So that's how when you exit and restart the game, you can like it saves the data. So that's that. That's pretty simple. It's listed pretty clearly in the Playdate documentation. So first, I'm setting the max height to 0, and I'm loading the game data. And if there is game data, then we'll restore the max height basically. And then I'm initializing the scene manager. So the scene manager, let me pull this up. This is a class that I made in order to handle scene transitions. So welcome, glad you can make it, Celine. I handle scene transitions with the scene manager. So this is kind of a question that I hear a lot, and it's also kind of confusing for like new developers or developers who've only worked in like engines like game engines like Unity or Unreal or Godot or whatever, is the concepts of scenes. So traditionally in games, you find a lot of scenes like a title scene, and then there's like a game scene, and then maybe there's like a menu scene or like different levels that are their own scenes. But when you're working with an SDK like Playdate, it's not like a built-in functionality to have scenes, um, as opposed to a game engine like Unity. So it's kind of confusing, I think, for people when they're like, oh, I want to create a new scene, or like have like a concept of scenes when it doesn't exist. So you have to essentially create your own implementation of it, or use a framework someone else has used. I believe the Noble engine is something that someone made that handles all that for you that you can use for the Playdate if you would like. But this is my own implementation. So this is how I do the transition. So the circle transition effect. I believe I had some questions about how I did that. Let me explain that here. So basically, it's a class, and the scene manager itself is a sprite, which has implications. But I'll touch on that later. Um, and basically, I'm just initializing some stuff. It's not that important. But uh, the method switch scene this is what's actually switching the scene. So what's happening here is I'm I'm whenever you want to switch a scene, you would call the switch scene function and then pass in this, which I'm determining as like I'm expecting to be a function. Um, and this function, I'm expecting it to be something which is just a series of calls that initialize a bunch of sprites. So what's unique about my scene manager system is I'm assuming that everything related to a scene is actually a sprite, um, which is that's just a design decision that I made from I decided. It's just arbitrary, but I feel like it makes things easy because for sprites, updates are self-contained, and you can easily remove all the sprites using GFX that sprite that remove all. And since for each of my scenes everything is a sprite, removing all the sprites in the game will effectively delete an entire scene. So let's just take a quick look into my game scene. This is what I'm passing into. So I said I was passing in a function, a function call in switch scene, and that's initializing the entire scene. And that's this. I'm passing setup game. And I call that here, pull up my title scene. So scene manager, it's a global variable, and I call switch scene and game scene. I'm passing game scene, which is I'm importing it from here. So notice that I'm not game scene is a function, but I'm not using like a or actually sorry, game scene is actually an object. Yeah, so what's happening here is this can be a function or I guess an initialization for an object. And what's happening is it's calling all these functions, these initializations for all these sprites. So each of these is actually a sprite class. So player, I won't pull it up, but you just trust me that each of these are a class that extends the sprite class. So I'm basically creating 5 sprites in this setup. So this is the creation of the scene. So um, if you're in like another game engine, you have like you have some sort of like scene object or something. But for me, this is the entirety of the game scene, um, which is yeah pretty interesting. It's not necessarily there's no right or wrong way to do it, but this is just what I found to make the most sense. So yeah, everything in my game is contained within the code of these 5 sprites. Um, and then these sprites can spawn other sprites. For example, the obstacle spawner spawns more sprites. But yeah, all the game logic is there. Um, uh, welcome home, Davis. Randomness. Is this making sense? If you guys have any questions, feel free to ask them in the chat. I'm more than happy to clarify or anything. I'm just kind of going off the cuff, and I don't know where everyone is at in terms of like technical knowledge, or if because I've been entrenched in this code base. So what seems clear to me might not be clear to everyone. So yeah, feel free to ask questions. So basically, this is my game scene, and what's happening is I'm creating the scene manager, and then it has a method called switch scene, and they pass in the scene, and I store that. So this is actually when I'm switching to the game scene, it's this game scene object that's being passed in and being stored into this new scene um, property. So new scene is now equal to game scene. You gotta rewatch this. Yeah, feel free to ask questions too. And so when we call switch scene, what happens is I create an animator, and this animator is animating between a circle radius to 0, and it's using this easing function. So basically, this radius will be some sort of value, and then it'll be easing into 0, right? So that's like the transition. This is it's just I guess it's a number. It's a number. So it's from this radius to 0, and it's going down like this, and it's easing in. So that's what's in this animator, and then over this amount of time, transition time. So 700 milliseconds, 0.7 seconds. And then I'm playing a sound, and then I'm of course I'm saying um, I'm storing this into this uh, property, and then I'm actually adding the scene manager to the draw list. So I mentioned that scene manager itself is actually a sprite. So the sprite gets added here. So once it gets added, now the update method is being called. Okay, so now that this is happening, what happens is I set self-transitioning into true. So once it's true, and once the animator is now a value, we go in this update function. What will happen is while we're updating, we'll see that it's actually this is not null anymore, and then the transition will begin. So what happens is how I do the transition is I get this filled screen rec. So I create a helper function. What's happening is I'm creating a new image, the size of the screen. I'm using push context, and I'm creating a rectangle the size of the screen. So right now, filled screen rect contains an image the size of the screen that's fully black and white. And what happens is I'm getting that. So this is filled screen rect is now a black rectangle that's the size of the screen. And then I get the radius from the transition animator, which I mentioned was transitioning from this radius down to 0. And then I'm creating basically a clear circle. So I set the color to clear, and then I use fill circle at point to draw a circle of radius based on the animator. And then I use it to basically cut a hole in the rectangle. That's what's happening. And then I set the image of the scene manager. Since scene manager is a sprite, I set the image of this scene manager sprite to this rectangle. And that's happening every frame. So maybe I can draw it out for you guys. So basically what's happening is when we have filled screen rect, this is a filled screen rect. Filled screen rect. And I'm basically drawing a clear circle into this. So I'm like cutting. Maybe I should have tested this before I tried to do this random drawing thing that I'm doing now. But yeah, I'm like, that's still black. So when the radius is, it starts off with radius 300. So the dimensions of this is actually, it's 400 by 240. And the radius is 300. So the halfway point is like 200 and then up to 300. So it's basically this big circle, like this big, outside of the bounds. And what's happening is I'm basically cutting this hole. So basically this whole thing is going to be white. Right? And as the radius becomes smaller and smaller, what happens is it becomes it goes like this. And then as this becomes smaller, there's like a smaller circle like this. And then this is what's being cut out. And then as the radius becomes even smaller, and then this part's being cut out like that. So you can imagine that it's this animation where I'm just cutting out a smaller and smaller circle into this black rectangle, which is called, that's what's making the transition effect. So is this how you make the underlying dithering patterns on the characters? So the dithering pattern, are you talking about when I show the results, or are you talking about just in general, the underlying dithering patterns? Yeah, you can use this method, like pushing context and stuff to do a lot of things, I guess. Yeah, let's see. So God Dog is asked, I heard Lua has coroutines. I'm not super familiar with them, but do you have thoughts about them versus a Boolean flag to wait on animations to complete? So I'm actually not that familiar with coroutines. I was hoping to research them as I was writing my PDF/book. But if I have any thoughts, yeah, I think coroutines are great as long as it makes sense to you. And I think you can definitely clean up. I think you can definitely clean up your code architecture if you use coroutines. And you know, and it could be since you don't have to use like Boolean flags and stuff. But yeah, yeah, it's just up to you. I think coroutines are probably would be a great choice. And then let's see. So like I have a ball rolling on the screen, but there's a pattern behind it that doesn't move. Well, if you have a ball rolling on the screen, there's a pattern behind it on the background that doesn't move, I would probably have it as a separate sprite. Like you would probably just if they're not at all like core like dependent on each other, I would anticipate that they would be like a separate sprite. So you don't even need to be worrying about that. Oh, thanks for becoming a patron. Yeah, that's very appreciated. And Isaac, hey. Okay, so continuing on with my explanation of the scene manager. So what happens is, so now I have this cutout rectangle, and then we're resetting the image on the sprite. So basically, every frame is redrawing that rectangle and setting it to the image, which is creating the animation. And then once the animation has ended, this is when we load the new scene. So load new scene does this. So basically, I remove all the sprites, and as I mentioned before that all my scenes are consisted solely of sprites. So basically, this is deleting the last scene. And then because the scene manager itself is a sprite, you have to re-add the scene manager itself. And then I create a new animator, but this time you can see it's the opposite of the last one. So it's going from 0 to the circle radius as opposed to the radius to 0. And so that's it goes in and then reverse goes back out. And then I'm setting just transitioning flag false just to let the scene manager know what to do. And then I called this new scene. So remember that I stored, like, let's say we're switching to the game scene. I'm storing the game scene object into this new scene. And by doing this, I'm basically initializing the game scene. So this self.new scene is calling game scene init, this init method. So when the scene is transitioning and the circle closes in, then it loads the new scene and then it starts transitioning out. So while it's transitioning out, you can see the scene will be existing. Will be like the game will be there. Yeah. And then so else if this is just checking if self-def transitioning in. It's not. If it's false, then we go here instead, and then we're just setting this to null, and then we're not updating the scene manager anymore. So that's the scene manager. Explain. That's how I do scene transitions. Hopefully that was helpful. If you have any questions, again, please feel free to ask. So I'll move on to the next thing, which is let me talk about. Let's talk about the game itself. So I'll start off with the background. So this is the background. This is how I handle the infinitely scrolling walls on the side. So if you remember in my devlog, I kind of touched on how I did that. Basically, I have this sprite. This sprite looks like this. And basically, I'm drawing. This is bigger than the size of the screen. So only this middle section is being drawn into the game. And as the player moves up or down, the screen is essentially going up. And then once it hits to this point, the screen hits the very top of this image or the sprite. Then I shift it up. And I'll show you how I do that. So first I set the image, and then I'm creating these collision boxes. So these are just the collision boxes on the left and right. And I'm setting the groups, and I'm adding it to the scene. I want to make a quick note about this. So you can set groups for collisions, and what I'm doing is that I'm calling this wall group, and this is actually part of my globals file. So I separate everything. I just define the numbers as global variables. This just makes it easier. So you don't have to remember that wall group is 2. You just call it wall group. So there's that. Interesting. Yeah, I don't know how that happened. No worries. Okay, yeah. So back to what I was doing. So this is, yeah, it is kind of ridiculous. So this is back to what I was doing. So this is how I'm updating. So basically, I'm actually, so I'm getting the draw offset here. So how I handle the height of the player is I'm actually just using the draw offset. So the draw offset is basically there's like a world space, world coordinate system, and you can set the draw offset to um, to basically draw from a different spot in the world space. So maybe I should do another example. Basically, so this is the default like this. So this is the coordinate here is 0, 0. And the coordinate here is 400 by 240. And what happens is when you do a draw offset of, let's say, you set the draw offset to 0, 10. What happens is it shifts everything down. So instead of 0, 0, it becomes 0, 10. And then instead of 400 by 240, it becomes 400 by 250. And everything that was, let's say there was an object here at 0, 0, it now appears 10 units down. So you can see that like the player, for example, is in the center, or actually the player is down here. And there's like a spike here. And what happens is when the player moves up, I'm increasing the draw offset. And what happens is then, because the player is moving up, but the player is staying in the same spot, but the player is moving up in world space, and I'm moving, and it stays in the same place because the amount I'm moving the player up by, I'm moving the draw offset down by the same amount. So what happens is the player stays in the same spot, but the spike is static in the world space, so it moves down. It appears to move down because we're increasing the draw offset. Yeah, I don't know if that made sense, but that's basically what's happening. Thanks. I'm glad you like the code readability. Yeah. So I'm setting the draw offset Y. So basically, this is how much the screen is being offset by. I'm doing some math basically. So what I'm doing is I'm essentially by taking the floor of draw offset divided by 120, I'm snapping the value of draw offset to multiples of 120. So when the draw offset is not this, when the draw offset, so the player's here. Let's say the walls are. I'll just pull up the image actually on the tile background. So basically, when the image is being cut off, or when the draw offset is like kind of halfway between in the image, what happens is it doesn't move at all. But the moment it moves up to here, what happens is the height of this block is exactly 120 where it repeats. And then once I know it's a multiple of 120, I'll shift it, and basically that's what's creating like the infinite tiling effect. Okay, question: am I from BC, British Columbia? No, I am not. I am from, where am I from? I was born in Japan, but when I was young, I moved to Michigan, and then I stayed there for a while. Then I moved to China. I lived in China for a bit, and then I moved to Illinois, and then I went to college in Illinois, and then I moved to Washington. So I'm in the greater Seattle area now. Yeah, so I would say mostly Midwest raised. But good question. Yeah, I don't know. Maybe my accent is a little weird. Yeah. Okay. So that's how I'm doing the infinite scrolling. Basically, it's just these three lines is how I'm handling the infinite scrolling, which is pretty nice. It's pretty simple. So there's that. Yeah, and then let's see, obstacles. Okay, so here's how I'm doing the obstacles. I have this parent class. So this obstacle extends sprite, and um, thanks, Josh. uh, and so um, obstacle is extending sprite, and basically it's very simple. So what's happening is the reason I have a parent obstacle class is I'm I'm checking whether or not something is of type obstacle, and then deciding whether or not to call uh, to end the game. So if we look in the player, go down here. Uh, okay, if collided object is an obstacle, then we set hit obstacle true, and then I would display the results, and then the player is dead. So that's why I felt like it was good to have kind of a parent obstacle class. And the second reason is that uh, I want the obstacle to be deleted whenever the player moves far past it. So basically, what's happening is so not this. What's happening is so the player is here, and there might be a bunch of spikes and stuff off screen or platforms. And what happens when you go really high? So you're like at like 300 meters up. Basically, all these obstacles are still loaded in the game, and they're hogging up resources with memory and everything, and especially the moving spikes. Since they're moving, you have to update these spikes constantly. So what happens is what we want to do is once the player moves past these obstacles a certain amount. So like let's say the player it's off screen, but then the player falls back down. You still want the obstacles to be visible, right? So basically, just as long as there's a big enough gap between where the player is and the obstacles where the player like won't fall down to that level again, um, we can just delete that. So I want all the obstacles to by default have that functionality. So what I do is I get the current height, and then I check if the gap between where the obstacle is and the current height is, then I just remove it. Hi, Ukulele Pichu. Welcome to the stream. So this is behavior that I want every single obstacle to have, and it makes it easy. It makes it so if I only need to implement it once, and then every obstacle by default can have this functionality if I choose to extend the obstacle update class or update method, which is great. Reducing code duplication and making abstracting all these functionalities away is good. It makes writing code easy for me. And so I want to mention something really quick about the get current height. So I'm getting the current height, and what is this function actually calling? So this is in my globals file, and what it actually is it's just the draw offset. So the draw offset is what I'm I'm just using this as a height. It's just like it just work. I guess it just because like however much the screen is being offset by is basically what the height would be. So that's kind of interesting. The way I'm doing it, and when I display like, oh, you're 10 meters up in the air, or you're 100 meters up, I'm just dividing this amount, the draw offset, by 100, and this is just an arbitrary amount. It felt like kind of like a meter. Let's see, class. So Ukulele Peach says, not like a meter nerd, but looks complex. Yeah, it does look kind of complex, but if you break it down, it's actually not as complex as you think. So this is just a name that you call this class, and then class is you're just creating something called a class, and then extending is basically you're just copying all the functionality from this other thing, GFX that's right. Is there a way to like ban someone? Yeah, okay, well, that's weird. Yeah, so um uh yeah, so it's not as complex as you think. It does look kind of complex, but once you break it down, I feel like it's especially for people who don't have experience coding or programming. When you kind of look at all this text, it's just kind of overwhelming. But if you really break it down to its core components, it's really not as difficult as you would imagine. Um, okay, so that's the obstacle class. And let me just go into how I did just a couple of these obstacles. So this is the spike class. So this is just the stationary spike. Um, it's so simple. So I extend the obstacle class instead now. So now this is considered an obstacle, and it has the built-in functionality of being deleted automatically if it gets past a certain height, and also it gets added to the draw list. That's being done here, and then so I'm just setting the image, and I'm setting the collision box. So I'm adding some padding here. So this is just making it so the collision box is just slightly smaller than the size of the image. And then I'm basically just picking a random x position between min x and max x, and then spawning it at that location. As for the y value, I'll get to that later, but that's being determined by obstacle spawner. Let's see, I'm using Panic's Nova editor to write code for the Playdate, but I see everyone else using Visual Studio Code. Does it make a difference when I write code in? So if I had a Mac, I would probably use Nova. But people are using Visual Studio Code because Nova is not available for Windows devices or Linux. It's a Mac only software. So that's why I'm using Visual Studio Code. I also use it for work and other things, so I'm just used to it. And also Nova Editor, I guess it costs money, and Visual Studio Code is free, so that probably plays into that. But if you have Nova, that's definitely since it's it's well supported, because from Panic. Yeah, I would encourage you to keep using Nova. Whatever you're comfortable with. There's no difference. I would say Nova is probably even better. Great question. So that's a spike. Yeah, it's just so simple, right? Because I don't know, there's just not much to it. The collision is being handled by the SDK, and I'm just moving it to random position, and it's extending the obstacle class. So that's just it. In terms of the moving spike, so here's how the moving spike works. So now the moving spike extends the spike class. So the spike class is the obstacle extends a sprite, and then the spike extends the obstacle, and then moving spike extends the spike. So with this dependency chain, what we're having is basically the moving spike inherits all the properties of the spike, which inherits all the properties of an obstacle, which inherits all the properties of a sprite. So you just get all that functionality for free, which is, that's one of the benefits of using object-oriented programming. And so, yeah, so basically I'm just setting a random value, deciding whether or not it should start moving left or right. I found that it was kind of weird when I had it moving to the right if it was closer to the right, and moving left when it was closer to the left, but it looked kind of like static, so I just randomized it. And then so you notice that I'm forgot to mention this. Oh no, I didn't. So this is important. So the moving spike is using the update method because I need to tell it to move left and right every frame. But the thing is, the obstacle class is already implementing an update method, and I want this functionality. So you have to call the super method or function. Um, so this is important to have this, or else the moving spike won't disappear once you move past it, and it'll just be stuck, in memory. And yeah, so thanks for your tutorials. Precious to have a Playdate mentor. Your code is not very good. Sorry. Have you got Pico 8 experience? Yeah, I've made one game in Pico 8. Yeah, sorry that you don't think my code is very good. I'd be curious to see what like good code is, but yeah, it works, and I think it's enjoyable to code in. So I don't have any problems with it. But yeah, if you have any advice, please feel free to leave it in the chat. So yeah, so the moving, what it does is if I'm moving right, I'm just using a Boolean value flag to keep track of that. Then I'm just using the move by function with the move speed property. So yeah, pretty simple. And then if it's greater than the max x, then we just reverse it. So that makes it so it moves left and right and left and right. So okay, let's go to what's another obstacle? The gate. Okay, so this is that kind of platform with a gap inside of it. Let's see. So it extends the obstacle class again, and I'm just kind of doing some math, I guess. This is not like, I guess, a great way to do it. But you know, I mean, when I was writing it, I was like, it doesn't look the great, but I guess I wrote this within yeah, like I just need to get the game. Sometimes it's just like you just need the functionality, and I'm not really gonna touch this code again. So as long as it works, it works. Which I find to be like kind of it's an interesting part of game development, and a question and a topic about like tech debt. So I there's this YouTuber. His name is the Fluffy Potato, who's a game dev YouTuber, and he had this video that talked about tech debt. So tech debt is when you write code that's not really well organized or architected, and basically you like if you were to go back to that code, it'd be very hard to make changes. So in this situation, kind of things are a little bit all over the place. And if I had to change something, like it might be kind of hard to change it. If I had to change the width and the gap and everything, that's fine. I just change these numbers. But with how it works, I would have to change it. But the thing is, I know that I'm not going to go back to this code, and especially because it's like I guess a 2-week project, and maybe I'll add more features and stuff. Depends on the reception. I'll probably work on another game after this. But in any situation, even if I add new features, I wouldn't be touching any of this gate code. So what is basically the point of me spending more time trying to optimize this code further or write it more in a more clean way or more well organized way? It's actually like it actually it doesn't really matter that much. So what's happening is like, so what tech debt is yeah, like I mentioned before, you're writing not that well optimized or well organized code. And what happens is it's called debt because like you're basically taking a loan in terms of time, how quickly you can implement something. And then in the future, you have to pay back that debt by having to work with that bad code or spend time refactoring it. But if it's like a small project, or something that is like you're probably not going to go back to, the thing is, you don't actually have to pay back that debt. So like sometimes I give you permission to write bad code if it works. Um, if you feel like if you feel like you're like, oh, this code is not well organized, how do I write this better? It's like hard to change things. Sometimes it's okay to just kind of rush through it if you feel like, you're not gonna go back to it or you're just trying to get it finished. Especially if you're a beginner, I would definitely say, because it's hard to tell like when you're writing code that's like quote unquote bad. Like code is bad when it's hard to understand and hard to manage and hard to add or take things away from it. Um, it's hard to understand, so you should just write it to make sure it works, and then you can kind of go back and then either fix it or learn in your next project. And which is why like I also recommend beginners to like make really small games, small projects, because you're gonna write bad code and it's gonna be really difficult to add things or change things in it. Um, and and then you're just gonna cry because you're like, yeah, like I can't. This code is so unmaintainable. But if you make a small project, you can just finish it and just move on, and you'll learn for your next project, and you write better and better code because you'll understand what it means to write maintainable code. So Tracy asked, so is adding new features easier than taking ones away? Yeah. So what I was talking about there is it just depends basically on how your code is organized. How like let's say if something is very integrated into your code and there's a lot of dependencies on that piece of code, it'll be hard to take away, right? And let's say another piece of code is, or your code is very tightly woven, and you want to add something that is integrated into that, then it'll be hard to add in because you have to like rewrite some things to make it easier to fit in. So, yeah. Um, okay, so this gate code, I'm just creating a random position. I don't know. It's hard to read actually. What am I doing here? I have this like gate width and a gap size, and basically I'm just using some math to make sure that like I'm drawing two rectangles. So you see this draw rect. So it's starting from 0, 0, and I'm drawing to this gate position, and then this other rectangle. I'm starting from the gate position, and then I'm adding the size. So the first rectangle is being drawn, like here, and then the other one is with the gap, and then it's at the end, and then plus a gap, and then I'm drawing the other rectangle, um, and then I create this other rectangle. So you can't add two separate collision boxes to one sprite. So I created this helper class that just creates an invisible collision box. Um, and then I use that here to basically create the two collision boxes for the gate, the platform with the gap in it. And yeah, that's all. So silently judging asks, is it possible or worthwhile to have unit tests to increase maintainability? So great question. So for those who don't know, unit tests are basically tests are pieces of code that you write to test your code. So basically, let's say you have a function. So you have a function add 2, right, number, and then you would write like some sort of function that takes in like your unit test would be like this. Let's say this code is return num plus 2, and then your unit test would be let's say like you'd have like local num, I don't know, test in, I don't, the naming is not very good, but just say like And then basically you would test all these different scenarios. So you do like add to, like result equals add to, and then you do test in one, and then you test like do another thing, test in two, and then you check the result and you'd assert if the result is what you expect, right? And make sure you don't have any errors or whatever. So basically, silently judging is asking whether or not it's worthwhile to add those kind of tests to your code. So it's definitely possible. And is it worthwhile? Well, that's up to you. I would say for a small project, no. This is kind of a topic of maybe some debate. But if it's a small project, I mean, this project is just a 2-week project that I'm not going to go back to. There's no point in writing unit tests because the effort required to write a unit test this entire piece of code, is just like, it's just going to add so much extra work for no tangible benefit. But if you have a big project that you're working like months or years on, definitely it'd be beneficial to add unit tests because, like, basically the point of unit tests is you save time in the long run, because instead of having to manually check every piece of your code, or you run into random bugs, you would write unit tests, and then those would catch all those bugs, and then all those and they would test things for you, and you would save time in the long run. But I would say in the short term, it's the time to write the test and how much time you save is negligible. Yeah, but that's my answer to that. Celine asks, off question, but when do you learn coding? It's a great question. I guess I technically started coding in middle school, maybe. So, but that was only a little bit, not really real coding, like kind of like Minecraft mods. I think a lot of people tried that in Java. I was just like copy pasting from tutorials. There's a thing called AppleScript Editor on Mac that my friend introduced me to. So I played with that a little bit and made like kind of simple applications, but nothing big. And then when I got to high school, I messed around with my calculator. So the Texas Instruments TI-83, and they have like a coding thing, like you can program in it using their language TI Basic. So I did some like I did some like coding on my calculator, making like a Pythagorean or the quadratic equation calculate like app or something really simple. And then, but that wasn't that much. It was really only until I think junior year of high school, my third year of high school, that I took like a computer science class, AB computer science, and I learned Java, where I actually learned how to code. And then, I went to university for computer engineering, and yeah. Yeah, so that's the answer to that question. So I suppose I've been coding for a bit now. I'm 23, so coding for maybe 6-ish years. Nick says, hey, yeah, welcome, Nick. Ryan says, writing your code to be unit testable will help a lot, though. Actually, writing tests for games, though, can be too much to be worth it. Yeah, that's a great point. Yeah, like thinking about tests. Thinking about tests as you're writing your code, if that's like your intention and you're making like a big project, that's definitely like a great point. Okay, so back to obstacles. Let's see. So one last obstacle is this floor spikes thing. So this is separate from the other ones because so those are the spikes that catch you if you're falling, so you don't fall infinitely. Please feel free to ask like off-topic questions and stuff. It doesn't just have to be about the project or anything. It's fun for me to answer. So the floor spikes, it extends the obstacle class, but it's kind of different because I don't actually want it to disappear when you're further. It should constantly be following you. So what happens is in the update method, I don't actually um, I don't. So if you remember from this one, moving spikes, I'm calling the super method. So this is getting this right here. So this is like kind of the disappearing code if you get too far from it. I don't call the super method because I don't want it to disappear. So that's kind of something too. You can purposely add, like include or remove it. So like override or extend those methods. And so what I'm doing here is I'm basically keeping track of the current maximum height that the floor specs is, and if it's if the player is like above that, or it has gone higher than where the floor, like the player, and there's like a gap, and then there's the spikes. If the player goes higher than that, then the floor should move up. But if the player goes back down, then the floor should stay in place. So that's just what I'm doing. I don't know. It's pretty simple, self-explanatory, I believe. And just setting a collision rect on that, and then yeah, and then yeah. Okay, so last thing with the obstacles is the obstacle spawner. So this is how I'm managing spawning the obstacles. So basically, these obstacles get spawned as you move up. So, well, you don't want to move. You don't want to like pre-spawn all the obstacles for many reasons. One is like the game is infinite, so you technically don't know how far the player will be moving up. So how do you know how far up you're supposed to spawn the spikes or the obstacles? Two is, you have then you'll be having a lot of these objects in memory, and they'll be taking processing power, taking up space, and all that. And three is, I mean, I guess those are two main reasons. Yeah, so this is the obstacle spawner class is what handles like spawning like those obstacles as you move up. So what I wanted to point out is that if you remember, I mentioned that sprites make up everything in my like in my game. So or each scene, everything is a sprite. So this obstacle spawner is actually, there's no image set on this obstacle spawner. So it doesn't exist as like a visual object. So you might not think it's like, oh, like a sprite, right? Because when you think of a sprite, it's like something that's like you can see in the game. But an obstacle spawner is kind of like a manager, like a managing system in the background. But because of how I set up my scenes, and everything is like a sprite, like, and in order to move away from like switch to another scene, you remove all the sprites. Like I'm setting the obstacle spawner as a sprite, and then I'm also adding it to the quote unquote like the draw list, even though it's not being drawn, because I want this update method to be called every frame. So yeah, that's something interesting to point out. Okay, so every frame. Oh yeah, glad to help, Jonathan. This is what this is for. So the obstacle spawner update. So what's happening is I'm getting the current height. If you remember, it's from my global file, which is it's just the draw offset. And then I'm basically doing this. Spawn height is math.floor current spike height divided by self.spawn. So basically what's happening is this spawn height is essentially like, because of the floor function, it's like coercing it into intervals of the spawn gap. So every 150 units or pixels, this is is what the spawn height will be. It's like a multiple of 150. And so so that's what's creating the gap in between, um, like gap in between each obstacle. And what's happening is the spawn height is, I'm just checking if it's greater than the last spawn height to make sure that like two obstacles don't get spawned in the same height. And then I'm setting this new last spawn height, and then so I'm doing some weird math basically with this. What's happening is, so the current height is interesting because, I'm getting it from the draw offset, but the draw offset is positive when actually the world space is negative. So let's say the player is here. So let's say the player is at let's say 30 meters up. The draw offset is actually 3,000. But the thing is, the player here is actually like at a world space of around negative 3,000, right? Because as you're moving up, you're going more and more negative in the y direction. So like the height, I'm like arbitrarily calling the draw offset the height, but really in world space, it should be a negative version of that. So that's why I'm taking the negative, the current height. And then I want it to spawn kind of above the player. So when you move up, it looks like the obstacle's always been there because it's moving into the frame. So that's what the offset is for. Yeah, that's kind of confusing. Yeah, it's a little bit confusing, but hopefully that makes some sense. And then I'm basically picking a random obstacle to spawn, and that's where the y value comes in from. So whenever I'm spawning an obstacle, I pass in a y value, and that's what the obstacle height is. It's coming from the obstacle spawner. Nick asks, pretty sure the game doesn't work this way, but as a theoretical discussion, how would you approach persistent obstacles? As an obstacle that you pass and go off the screen persisting if you fall down. Yeah, so it actually does that. Oh, I see. Maybe in terms of like performance, maybe. I mean, yeah, it depends. Depends on like if depends on how many objects there would be. If there's like not that many, and maybe if there's like a limited height, you could just keep the object persistent in memory. I mean, if they're persistent, then you would never remove them, basically. Um, uh, and and then you'd only remove them when the game like restarts, or like when you die, and then you would and then you restart the level. That's the only time you would remove them. But I don't know. You might run into some performance issues, or you might run out of memory. It's possible, but maybe not. I don't know. I haven't. Yeah, it depends. I haven't really tested it. You can kind of like. I mean, let's take a look here. Okay, so I'm gonna comment out this line and run the code, and then I'm actually going to run this on my Playdate. Let's see. Let's see. Show. How do I do this again? Okay, I can say install it to my device. Hi, obsessive compulsive gamer, OCG. Let's see if this works. I actually don't remember. I'm trying to show not that. Show. Oh. Oh yeah. So this is showing the device info. Um, I actually don't know how to ban someone. Okay, so I'm running the game right now. If you see here, I don't have it. But basically, you can kind of see the memory going up. Maybe I shouldn't do like a live demo. Okay, anyways, I'm just going to scratch that idea. That was a fail. But yeah, I don't know. I would say just test it out yourself, because sometimes you don't like optimizations aren't really necessarily necessary until you don't have to like pre-optimize something. Like just try it out, and if you're running into issues, then you can go back. But let's say in the worst case scenario you are running into issues and you do want to have that behavior, what you could do is like set up a system where you save the the type of object and also the height that it's at into like a table, and not the sprite itself, because then you're only storing like two pieces of data, like two small pieces of data: the height, which is just a number, and then the the type of object, which is just like a reference, or it could just be a string, like a name. And then once the player is moving down, you can respawn that object back in that location, which could be an optimization you could do, if that makes any sense. Okay, moving on. Past that obstacles, let's go to the player. Okay, so the player is a long file. Let's see, how do I do it? So I just draw the player here. It's pretty simple. I just drawing a circle. And this is the collision box. Okay, well, here's what I wanted to talk about. So I'm keeping track of the velocity. And so, yeah, thanks for stopping by. So I'm keeping track of the velocity. So what I'm doing is I'm like simulating physics basically with the player, which is it's simpler than you think, because if you think about it, like in terms of like velocity and acceleration, like position. So there's like three things: it's position, velocity, and acceleration, right? And they're basically like higher orders of the other. So when you're moving, uh, when a position is like a when a position is like when you're moving, position is just like a number. But when you have velocity, what's happening is you're you're moving the position by the velocity and every frame. So in game dev, it's like every frame. But for acceleration, what's happening is instead of what you're doing is then you're adding some amount to the velocity every frame. So what's happening is you just have basically just three variables. You'd have the position, and you have the velocity, and then you have the acceleration, and you're just adding them. And that's just how you do physics. So this, yeah, That's all there is to it. So I'll get into that in a bit. So this max velocity, this is just max cap on the falling. These are like different accounts. Yeah, because it's like different accounts. I can't even ban one of them. Yeah, it's horrible. Yeah, I'm not really sure what I can do about that. I'll look into this after the stream. Okay. Or maybe I can. See if I can change some settings. Sorry about this, guys. Channel. I'm trying to figure out how to ban words. I'm not sure how to. Okay, well, I'll just figure it out later. Okay, so we'll just have to deal with this for now. Okay. Yeah, so yeah, back back to the player code. So I just have these variables set. Let me just show you what's going on. I'm calling this launch method, and basically that gets called by the laser gun, and it's just setting the velocities to these launch variables. And so I'm just using some math. If you don't know, like, if you take an angle and you take the cosine of it and the sine of it, what happens is, let's create a new one. So let's say we have an angle here, right? If you remember like the unit circle from your math class, I'm basically using like the unit circle. So let's say you have 0 degrees, 90 degrees, 180 degrees, 270 degrees. And then let's say you have some angle like this, right? So this is 45 degrees. What happens is, like, you have this angle here. This is 45. And if you take the cosine of this angle, cosine of 45, what you get is basically this this amount here, this x amount. And if you take the sine, what happens is you get the y amount. So this is sine of 45. And this is the cosine. It's turning into like a math class. So what you can do is, and this is and then you and it's like the x and y for like a unit vector, so a length of 1. So that's basically what I'm doing here is I'm getting this angle, the x and y values of this angle, and then you can multiply it by the launch strength, and basically you just get an x amount and y amount that like that you can move the player by, like that you shoot the player by. And the reason I'm doing minus 90 is because what I want to happen is I want, like, so with the crank, like when it's pointing up, I want it to be like when you get the SDK when you call the SDK function method to get the angle of the crank, but like directly up is 0, and then directly down is 180. But directly up is 90 in this case, right? And directly down is 270. So what you can do is you just subtract 90, and you're basically shifting the unit circle over, and you get 0 to match basically the angle. Like, I guess I can show on the Playdate. Like directly up is this, the SDK gives you an angle of 0, and directly down, the SDK gives you an angle of 180. So as opposed to like on the unit circle, like this would be 0, right? Or this. I don't know what direction. But yeah, so I'm just creating an offset by subtracting by 90. And then because it's Lua, you have to convert to radians. So yep, there's that. And so here's how I'm managing the velocity. So what happens is with the y velocity, I'm adding 9.8 divided by 30. I don't know how to block someone. And they're also all different accounts too. So you can't even block like the one account. Yeah, I don't know what to do. Okay. Yeah, the unit circle, right? I mean, I didn't have to use this much math until I started doing Playdate development. It is what it is. So for the y velocity, I'm adding 9.8 meters, 9.8 divided by 30, because what's happening is I'm just using the gravity constant. So the player is like, I want the like, so this is like when you're adding something to velocity, that's acceleration. When you're adding and subtracting something from velocity, it's acceleration. But when you're adding and subtracting something from like a position, then it's velocity. So like I'm adding 9.8 meters per second to the y velocity, which is causing it to accelerate every frame, which is causing it to accelerate by 9.8 every frame. But then I divide by 30 because I want it to be per second, and it's running at around 30 times per second. So you know that you have to divide by 30. And the reason I'm adding it is because like downwards is positive in the Playdate coordinate system, which is pretty common in game development and programming in general. And this is, I'm checking against the max velocity. This is basically the terminal velocity. So if it's moving downwards faster than a specific amount, then I just cap it out at the max velocity. So question, hey, will you make a tutorial on how to do a system to save your progress and resume later? Um, uh, Probably at some point. It's probably not for a while. Chase, like the bank. So the Chase logo. That's funny. So if you did more than one rotation before the frame updated, you'd have no way of knowing. So I believe there's another. Let's look it up together, actually. Um, so of course, let's see, crank. Reading crank input. So look, you would do get crank change instead of the. So I'm getting the absolute position in my code because uh like that's all that matters for me. Like I don't care about how much you're cranking by or anything as long as like the position is accurate. Cuz like let's say you rotate like a million times in one frame and then you end up like pointing to the right, then that's the position I care about. But let's say you do care about how much it's changing by. Let's say like it's affecting like the speed of something or whatever. Then you can get crank change, and then you would know, or get crank ticks. Um, so there's the answer to that. Um, okay, so so this next thing is the damping. So this is kind of a unique thing that I added. So basically, I found that when um, you're moving left and right, basically, like it felt weird when it was like a just kind of like it kept going, sort of like, and it wasn't slowing down. Maybe I can show it here. So this is without damping. Um, you can see like it moves like the X position is like a constant moving, like which is like pretty weird. I don't know. It just didn't feel very natural to me. Um, but when you add damping to it, then you kind of like slow down. See, which I felt more natural, and it kind of gave you more control, sort of. So that's what the damping is doing, if that makes sense. Um, and it's just kind of something arbitrary I added. You can think of it as maybe like air resistance, um, and I'm just subtracting or adding it based on the direction. Okay, so this is how the player position is actually changing. Um, so um, yeah, and then so this is how it's actually changing. Basically, um, like I would just add your when you're adding something every frame, it's like that's what the velocity is. So I'm just changing the position every frame by the velocity. Um, and yeah, so and then where does the player get new X? Oh yeah, move with collisions. So that's how what's actually moving the player. Um, and so I'm also the laser gun is actually like a child object to the player. So I'm moving it with the player. Um, so move with collisions. Let's see. Yeah, so I'm moving with collisions and I'm checking collisions. So basically, I'm just checking if it's an obstacle, if I've collided with any obstacle, and if that's true, then I'm displaying the results, and that's it. And otherwise, I only have two collidable types of objects in the game. One is the the obstacles, and the other is a wall. So I don't even bother like checking if it's a wall or anything. I just know it's a wall. Um, and then I just reverse the x velocity by multiplying by -1, and then I subtract a wall boost amount to move the player up. So that's how the wall jump / boost is happening. Yeah, and then so this is the where I set the draw offset. So how everything is like kind of dependent on the draw offset to get the height. That's how I do it. So I'm doing it like so. Yeah, and that's pretty much it with the player. Um, let's jump into the laser gun. So here's the laser gun is kind of interesting because I'm drawing it kind of with like, yeah, I'm drawing a line. So there's kind of some math involved, and I'll show you how I do that. I think I came up with a pretty like a decent solution. So let me just show you the gist of what's happening in this. So again, I'm using like the trigonometry. Basically, I'm creating an image like this. So like a big square image, and I'm taking the angle of the crank. So I'm starting from this center position, and then I'm taking the angle of the crank. So let's say the angle is like 180 degrees. So the crank is pointing down. So I know the crank is pointing down, and I have that angle, so it's 180. So from this it's like 180 degrees. And what I do is I take um, and then I use that angle to somehow get this position right here. And I draw a line between those positions. And the way I'm getting this point, um, yeah, this sucks. Oh my god. Yeah, I'll figure this out after the stream. How to deal with that. What a nightmare! Oh my gosh. So the way I'm getting that point is by using this get line at angle. So yes, it's basically the same math that I was doing. So I'm just using the cosine and sine to get some sort of x and y value, um, and then I'm so let's say it's like 180. Basically, it'll by taking the sine and cosine of it, I'll be getting 0, 1, I think. Yeah, something like that. Um, and uh, and then I'm multiplying this by how long I want the line to be. So I think it's 25. So then this would be like 0. This point will be 0, 25. From like if the center is 0, 0, right? And this will be 0, 25. And then that's how I get like that line. And yeah, thanks for understanding, guys. So here's that image. I'm laser gun length times 2, so I'm getting 2 times. So actually, this is probably more like this. Like this is the whole line. It's taking up the whole space. Yes. So crank at the top is crank at the top. Yeah, crank at the top is 0 degrees and bottom is 180. That's correct. So what's happening is I'm creating this image that's double the length of the laser gun to make sure that I fit the entire gun in this image. And then I'm getting x1 and y1 as basically. Oh, sorry. So here's how I'm doing it. So basically, this is 0, 0. And I'm adding some like I'm adding the length of the laser plus some padding, I think. And it's like up to here and then to the y value. So the length of the laser gun. So this is 25 and this is 25. So this would actually be like 25, 25 in the center. And I'm getting the angle from the crank, and then I'm getting those two positions two values, and I'm adding it to x1 and y1. So while this would give me 0, 25, I add this to 25, 25. And what I'm getting is like 25, 50, which is this point right here. And then what I do is then I just push this laser image to the context, and I draw that line from x1, y1 to x2, y2, and set that image to the laser gun image. So basically, what happens is like I can any angle, I get the x and y coordinates, and then I multiply it, and then I can just draw it into this image. And wherever I move this image will be moved onto the player, like superimposed onto the player, and then that's like what's creating the laser gun, if that makes sense. The question is, how do you change between title screen and the game? And if you have more scenes like inventory or shop, how can you manage all that? Yeah, that's a great question. So I actually talked about that earlier in the live stream, and you can check the recordings like later on. I'm also editing it into a video. But the way I do it is using something called the scene manager. So everything in each scene is made up of entirely sprites. And what's happening is when I change scenes, I'm removing all the sprites, and then I'm calling an initialization. I'm removing all the sprites, and then I'm calling it some sort of initialization that initializes all the new sprites of the next scene. And then in the middle, I'm doing these transition animations. So that's what's happening. Just like a SparkNotes version. Yeah, okay, so that's how I draw the laser gun. The math is a little bit complicated, but not too complicated. And when I shoot, what happens is I call the launch method on the player at the angle that I'm at. And then I handle the shooting from, I think the player calls it, let's see, player, yeah, if button pressed. So if any of these buttons are pressed, I call the shoot method on the laser gun, which, yes. Yeah, I see. If you had an inventory or pause button deleting every sprite, wouldn't it mean that you have to start again from the beginning? Not necessarily. So that's a good question. So what I do is I remove all the sprites, but then I add back in the scene manager. Or you can have, so the scene manager itself is a sprite, but you can also make it so the scene manager is not like a sprite itself, and then it won't be affected by removing all the sprites. So yeah, there's that. So that's how. So because I'm removing all, and then I'm adding it back in, and so I'm removing them, but immediately after I'm adding a bunch of new sprites. So within the same frame, I'm removing it all and then adding them back in. So the game doesn't really stop or restart. Yeah, and Mahashinder says, is there a way to mod people on YouTube? Probably. Yeah, do you want to be my mod? If you can help me, that'd be great. I'll make you a moderator. How about that? Okay, it's your job now. Thank you. So, let's see. So, yeah, scene manager. Okay, we talked about that. Laser gun shooting. So, okay, so that's all handled, all the physics, but there's actually still like a um physical like or like a visual laser beam that I shoot out, and that's from this laser beam class. Um, and so it's just like it's just all graphical. But what I do basically is I just create a timer, um, and I'm easing between a beam width, which is 10 to 0, using like an easing function, and um, every frame I'm just redrawing that image using, you can see here, this block of code. I'm drawing it based off the beam length, and the beam length gets updated every frame to the value of the timer. And yeah, that's all it's happening. And I'm basically using the same math again, the whole unit circle math I was talking about, to decide, like, to figure out like where the line should be drawn. Okay, yeah, that's all with the player. Let's move on to the UI. I think we're getting close to the end. It's taking longer than I anticipated, but it is how it is. So, height display. So this is just what's like on the top left of the screen that shows the height. It's pretty simple. I'm ignoring, it's another sprite. I'm ignoring the draw offset, making sure to do that so it doesn't move with the world space. It just stays in the top left corner. And then I'm just creating an image with the text by doing draw text and setting that on the sprite. Pretty simple. And the result, okay, so, and then the results display, that's like what comes down, what animates down when you die or you hit an obstacle, and what's going on with that whole transition. So yeah, this is a little bit complicated. So if you remember, there's kind of this like a fading animation in the background. So what I'm doing is I'm like, what I did before is I was calling this draw faded function in my update method. And so every frame I was calculating this faded image to superimpose onto like the background. And what was happening was it was kind of lagging. And I found a solution to this, which is I just pre-compute everything. So what I'm doing is I'm creating these images that are fully black, and then I'm fading them with this dithering algorithm, and I'm storing them into this table, like a dictionary. So this is like the fade amount basically. So it goes from 0 to 55, and in increments of 5. And basically, I'm associating these numbers, so 0, 5, whatever, up to 55, to an image that's faded. So that makes it so during the game when it's being run, I don't have to like draw faded is like a kind of a complex like math operation that has to do all this stuff to try to figure out how to create this faded image. And instead, I store it as like an image, and I'm putting it into this table. And yeah, so like during like runtime and when it's updating, I don't have to recalculate this. I just access it from this table. And this runs in the very beginning of the game. So that's like kind of a solution to yeah, that to like my performance issues I was getting. Yeah, I've seen that before. Lua is the code for Roblox. I've never actually played Roblox, but that's pretty cool that you know, that's the thing. So let's see, results display extends. Yeah, so what am I doing here? So I'm the thing I'm animating is I'm animating the background, but I'm also animating like the actual dialogue coming down on the screen. Um, so let me just pull this up again to just to remind everyone what's going on. Um, oh yeah, you see like the background gets faded, and then also like the dialogue comes down. Um, so those are two things that are being animated. So I made animators for both. So the snapshot animator is for the background, and the dialogue animator is for when it's coming down the screen. Um, and so I'm creating those two animators, and um, when it's animating in, I'm just doing some math basically to basically take this. So I'm animating from 0 to 50, which is like the faded value, and but what happens is like they're not guaranteed to be like integers or like multiples of 5 or integers or anything. So I'm doing some math to basically round it to the nearest um, multiple of 5. And what's happening is I can grab an image, like a faded image based on like how faded I want it to be with this dictionary. And it's pre-computed, so this operation is pretty quick as opposed to the slow fading method. And then I could take that and then basically I take a screenshot of the game. So I stored a screenshot of the game, the last frame of the game when you died or when you hit the obstacle, and I draw that, and then I draw the faded record on top of it. So here it's like this is the screenshot of the game in the background, like right when you hit the spike, and then I draw this like dithered pattern on top of it, and that's just creating the fading effect, and then I'm setting, yeah, that sprite. Um, and then this is moving the dialogue down. So the height dialogue is a separate class that I'll go to later. And then yeah, and then when it animates out, I'm just moving everything down like that. So pretty simple. Um, yeah, and then yeah, this is so when you hit an obstacle, it actually removes every sprite again from the game. So it's like kind of like a scene transition. You can think about it that way. Um, so display results. So this is what's happening is like when you hit an obstacle, this function gets called. And this is a screenshot that I'm taking. So you can use this handy like graphics.get display image to basically get whatever's on the screen. So that's what's happening when like I do this transition. I'm just grabbing the image from the screen, and I'm storing it into this snapshot. I'm resetting the height by setting the draw offset back to 0, and then removing all the sprites. So this removes everything like with the game. So all the spikes and obstacles and everything. Um, um, and then I create a results display. The question is, I don't think I got it the first time. You pause the game and then resume it. If you clear every sprite and then adding it back, how do you remember where everything was? Oh yeah, don't worry about asking it. I don't think it's not like super easy to understand. Yes, like you don't actually need to remember where anything was because none of the data that you remove is actually important. Like it's like when you're transitioning, so when you're displaying the results, you're removing all the sprites, and then you're creating a new sprite, which is the results display. But none of the data, so all the data that's stored in the game is like where all the spikes are, um, what what position the player is at, um, and everything like that. It's actually like you don't need it. Like you don't need to know any of that information when you're starting a new like run. Um, and so that's why you can remove everything. Um, like the only data that you're kind of keeping track of is like the max height, for example, and the max height is stored in this global variable, which is going to be persistent. Uh, does that make sense, or I can explain it more? Yeah, like for example, like this remove all function. Yeah, if it makes sense, that's great. Yeah, so like you remove everything, but immediately after you're adding another sprite, and so you're not stopping anything. It's just continuing. So yeah, we remove all the sprites, so everything from the game is erased, and then you call this. So like right as the instant you hit the spike, actually everything about this game state is deleted because you remove all the sprites. The only thing that's saved is the screenshot that gets passed in the results display. And so now the only thing that's actually on this in running in the game is this results display sprite. So yeah. Okay, and then the dialogue that comes down it's just a bunch of text basically. I'm like manually like this whole box and this text and everything. Press A to restart, all that stuff. I just manually like just wrote some functions to draw it out. Yeah, it's just a bunch of draw commands. Like I push the context of this image and then draw everything, pop it, and then set the image. And that's pretty much it. Okay. So the game scene, I think I basically went over this already. The title. So I think the title's the last thing that I'm going to go over in this stream. Yeah, so let's look at the title again. So yeah, looks pretty good, huh? So yeah, this idea to basically have everything animating in. Let's watch that one more time. So these are all like just manual, like I just created these animations manually, basically. So if you look at the title, I have it stored where they're all like separate images. So it's like a player. If I open a sprite, like this, they're all like I see them as like different. They're like different layers. So basically, like there's like the walls, like its own image, the player's its own image, the spikes are its own image, the title is its own image, and this like prompt is its own image. And so I'm like loading all these into their own sprites, and I'm just setting the start position so they're like off the screen, and I'm moving them off the screen, and I'm just creating animators for all of them. And this is just like I just like fiddle around with the numbers sort of. And then I'm using this last argument is just like how much it gets delayed. So they're all getting called, but like these ones are getting delayed kind of. So then they come in at different times. And then I have all these sound effects, and I'm using this like play at to kind of delay the sound effects of each thing. And while it's animating, I'm just moving it to the animation value, like where the animator is, and that's all there is to it really. And then it's just like you're just playing around with the numbers, but it's just kind of a lot of manual work to get those kind of animations, but it's really not that bad. And then once the animation is finished, I'm set animating to false, so then it goes into this else block, and then like what's happening is I start the blinking of the prompt. So the prompt starts blinking. It's just using I'm just using a blink animation.blinker thing. And then I'm just checking if the button, like the player presses A. And then I switch to the scene with the scene manager. How many hours would I say I put into this game? Uh, okay, so it was like 2 weeks of work. Um, and then I worked on it. Let's see. Each week I would work on it for like, I don't know, like 4-ish days out of the week, 4 or 5 days out of the week, because, and then the end of the week I would use to like to script and edit the video. Uh, um, yeah, and then so let's see, and every day is maybe like 2 hours, let's see, 8, 20, maybe like 20-ish hours or 30-ish hours, 20 to 30 hours, maybe. I don't actually know. That's a great question. Yeah, but I did spend a lot of time on it, and yeah, this stuff takes a long time. Even like being like experienced at coding, I'm still learning stuff with the Playdate development. Yeah, and like I'm like a professional. Like my job is a software engineer, so like I'm like I have a lot of experience coding and stuff. And it still takes me a while. So, and I still had to like cut down features like with the scope creep video that I put out. So yeah, it's hard work. Yeah, every image I use is 400 by 240. That's right. I knew that going into it. I was like, it would just be easier this way. So yeah, and let's see. Do you tweak the art after coding the game or create all the art beforehand? That's a great question. Um, so I mentioned in my last video that I put out yesterday that I wanted the player to kind of be like an alien or something, but I just didn't have time. So I kept it how it is. So that stayed kind of the same. The spikes. So it's just like I make this I make the art as I go. So whenever I need something, like let's say I'm like implementing the spikes, then I go and draw the spikes, um, and then I add them in, and then uh, and then like the title screen when I was making I made the title screen near the end, so I drew like all this stuff. Like I mean the title screen is like it's just copied from the game, so I mean, like, look at this is super simple. Like when I was making the walls, I like drew the walls. Yeah, I mean these sprites are super simple. I'm not like super good at art or anything, so it's like programmer art. But yeah, keep it simple. Then it's better to be simple if you're not that good, I guess. Um, yeah, I didn't really tweak the art or anything. Uh, oh, thank you. That's really nice of you to say it. Glad you like the tutorials and thank you, Silently Judging. You say my art is looking great. Yeah, I love answering questions. This is really fun for me. Uh, yeah, like I honestly like I like uh, I like teaching like coding and stuff and everything. Um, and no one ever listens really like IRL because like no one else like that I know is like really interesting in programming. So like having people to talk about this and like be able to like teach it is like really nice for me. Uh, if I ever need art, let me know. Yeah, for sure. Um, yeah, thanks for the offer. Yeah, so anyways, I think that's pretty much it with my entire like game architecture. Hopefully it was helpful. Does anyone have any like other questions about the game architecture or just about anything in general? Um, I'll probably keep the stream going for another maybe like 10 minutes to answer questions. Yeah, feel I guess this turned into Q&A now. um, but yeah, this is good first live streaming experience. This is kind of new to me. It's a little weird, and yeah, weird bot stuff. But I'll figure that out. Um, do you have a full series release plan? No, I don't. I don't have a commercial game or anything planned. It's so weird being like kind of like a game development YouTuber because like part of your um like you're kind of making a game for a video sort of in a way. But even more for me, I'm making games to to get better at development, like Playdate development. So it's easier to get like better at it when I'm like iterating on like short, small games. Um, yeah. So I would love to make like more of a longer commercial release, but it's not really feasible for me to like invest that much time into it because like I don't know, I feel like it'll just take a really long time. Uh, just join. How do sheets work? Um, it's a great question, Zach. So I didn't use sprite sheets in this game, but uh, I can show you really quickly, or just describe it to you. Probably won't show it, but uh, where is this sprite image table? Yeah, so basically you use image tables, um, and you have to like name the file. So it's kind of weird, but um, like your file name has to be like the name of your file, and you append it with dash table and then width and height. So width and height is the width and height of each sprite. Um, so that's like that's how you do like a sprite sheet, and then basically you can load it and you can create a new sprite sheet using this image table.new, and then you pass in the path. And then um, yeah, that's how you do a sprite sheet. Do you have any specific questions, Zach? Um, I'm not really sure exactly what you're struggling with. I, grant money to make a full commercial game. Wow, that's crazy. Wow, that's really exciting. Yeah. And does anyone have any other questions? Could be about anything, I guess. I think I'll probably do more of these live streams. I did mention in the poll like other options for live stream things. I was thinking like like a code review or something, where I would like maybe I can like look at someone's project and see like what their code is like, and maybe give some comments or and feedback on it. Another thing is like playing through Playdate games. So pipeline for like making a game, or my YouTube channel, or like YouTube videos. Yeah, like playing Playdate games and stuff, and make commentary on that for live stream. Game, okay. Oh yeah, glad I can help, Zach. So for a game, what I do is, so I start by like thinking about the game idea. I guess it's pretty obvious, but I do kind of like I try to imagine it more like in depth, sort of, and think about all the systems and everything. And I think about like, uh, I think about like how difficult things would be to implement, um, like, uh, and um, yeah. So that I just imagine all the game mechanics and everything, how it would work together. And then when I start with the game, I don't know, what do I do? I guess I just implement like I just pick something to start working on, because I think that's like a big thing. It's just like the hardest part is just getting started. So I just pick like maybe probably like a core mechanic. So like with this game, I did like the player and like the gravity, which is like a core mechanic. Um, and uh, and then I just implement that, and then I just kind of build around it. So like I basically focusing on one scene, like the actual gameplay, And I just keep building around it. And then once I get to the point where there's like I need like the title stuff and like other scenes, then I kind of like attach those onto that main scene somehow. Like I fit it in. But I make sure to just start like focusing on the main gameplay. And then I would probably like if the art is important, I would just do like the minimum amount of art needed to like, or maybe some sort of prototype art or something just to get it working kind of base game. And I just keep adding onto it. And then what I do is I finish everything and then I add sound effects. Yeah. Sorry, that's not very like specific, but that's pretty much what I do. Um, so I wish I could pronounce your name. I don't know how to pronounce it. Andreklo. I don't know how to pronounce it. Sorry. Didn't see the scene. So how to use animations? So I actually don't know, which is funny. I haven't worked with animations at all yet. So I was gonna do like an animations like tutorial, but I got my Playdate in my hand, so I was like, so I just had to make games for it. So I stopped making tutorials for a bit. Um, but I was gonna learn, but I don't actually know. Silently Judging asks, "What's your favorite non-Playdate game?" Um, it's Melee, Super Smash Brothers Melee for the Nintendo GameCube that came out in 2001. Um, that's my favorite non-Playdate game. Other games I like are uh, uh, I was like obsessed with Slay the Spire for a while, but I don't play that much anymore. Um, and then uh, and then I guess I like Minecraft a lot, but it's been a long time since I played that. Um, I did recently play a short hike, which was amazing. And uh, I like Minesweeper a lot. uh, um, but yeah, I don't these days I don't play that many games. Unfortunately, just don't have the time, I suppose. Um, I wonder why the bot chose the stream. Yeah, I feel like it's the bots have like they just have their own YouTube account, and then whatever comes up in their recommended, I feel like it just automatically goes into that thing. Um, do I play competitively? I guess I don't know. I feel like I'm probably like I'm definitely much better than like a casual player. But if I'm playing against someone who's actually good at melee, then like I would get washed. Or like at my school, I sometimes enter tournaments and stuff. Or like I entered some tournaments, but I just get destroyed. Have you ever tried Hyper Light Drifter? Oh yes, I have played Hyper Light Drifter. I played on the Switch. Yeah, it's amazing. Um, it's a great game. I honestly like. It's so weird because um, I like that it wasn't like too long of a game. Like I don't think like it's like my time is so important that like it's like I can't play like long games. Like it has to be like somewhat like it can't be like super long. Like these big AAA games. That's why I love indie games so much. One, because indie games are amazing. It's like so much character and personality. But the fact that it's like not as long is actually a positive aspect to a game. Um, yeah. Uh, okay. I think I'm probably gonna end off the live stream here. But thanks so much for coming, everyone. I got a new mod, Mahesh. Uh, it's just kind of random, but thanks for sticking with me. This is my first live stream, and also like dealing with the random bot thing and stuff. Hopefully, this will be like I can somehow cut this up into a video. Um, yeah, because this is supposed to be my video for next Monday, and I'm supposed to like cut this up somehow. But hopefully, I was comprehensible. Um, but yeah, uh, yeah, this is great. I'll definitely do this again sometime. But yeah, it's been about I think 2 hours ish. So I'll let everyone get back to the rest of their day. And thanks so much. All right. See you guys. Bye.